Thank you so much for inviting me to this very interesting meeting. And today I will talk you about our approach we are using and testing on a small island that is Procida, an Italian island in Mediterranean Sea, where we are trying to set up the proper condition to apply the sterile insect technique against the Asian tiger mosquito, Aedes albopictus. And we are trying to work, let's say, to produce something new, some new approach to involve the community in helping us in get these important results for the island and for our region, that is to free an area from this kind of vector mosquito, this species of this vector species. So, as you know, mosquitoes are considered the world's dirtiest animal species. It's able to kill every year more people than human. So it's really a big problem. And according to a recent study published on the Lancet journal, in less than 8 years, up to 8 billion people could be at risk of mosquito-borne diseases. So between mosquito species, invasive mosquito species such as mosquito of Aedes genera are considered of, let's say, special interest because of their prominent role as vector of disease, and also because of their capacity to invade novel environments. And this is exactly the case of Aedes albopictus in Europe. This species arrived in 1990 in Italy, in Genova city, and then quickly spread over most of Mediterranean countries, and recently started to move also to northern regions. The fight against mosquitoes, as for many insect pests, has been done to date mainly by the use of pesticides, but this approach is, we can say that it's a blessing and curse approach because of side effects on these substances on the environment. For example, the problem with the beneficial insects that could be eliminated with the same substances, and also the problem of resistance occurring in vector population, as discussed in previous session. An eco-friendly alternative approach for vector control could be considered is the sterile insect technique, as briefly shown in this video produced by the International Atomic Energy Agency.
Mosquitoes. The battle continues, but the battlefield is changing. Throughout the millennia, people have fought mosquitoes and the diseases they transmit. Now, with globalization and with climate change, mosquitoes and diseases are spreading. Mosquitoes are becoming resistant to insecticides. The diseases they carry are becoming resistant to drugs. And mass use of pesticides required for control has negative effects on public health, on beneficial organisms, and on the environment. But there is another battle plan. The sterile insect technique, SIT. SIT is a type of birth control for insects. Already successful in controlling major crop and livestock insect pests, SIT is being refined and validated to control mosquitoes. Special factories rear millions of male mosquitoes, sterilize them with radiation, and then release them into target areas at regular intervals. Mate with the wild females, but the males are sterile. There are no offspring. When sufficient sterile male mosquitoes are released, each successive generation will have fewer wild mosquitoes, and the population will be suppressed. Success will depend on people in villages, towns, and also cities. Collaborating with public campaigns to eliminate mosquito breeding sites in combination with traditional control methods and the release of sterile males. This integrated management reduces the mosquito population enough to prevent disease transmission and nuisance biting. As there is no environmental pollution, no development of resistance, it is sustainable. SIT offers an additional method to control mosquitoes and the diseases they carry, and thus to reduce human suffering in many parts of the globe.
So I am a molecular geneticist, and I work in my laboratory at the Department of Biology of the University of Naples, Federico II, on sex determination genes that could be used to improve the sex separation system for the sterile insect technique. Because for the application of this technique, just males are released, because females, as for agricultural pests, are the main agent of damage, and in case of mosquitoes or other insect vector species, they can transmit the disease even if they are sterile. So you need just males. So since some years, I also began to deal with the application of this control method in the field, trying in particular to contribute to the improvement of one of its key aspects, that is the participation of a community living in the area subject of control programs. In fact, without the participation of the community, the battle against mosquitoes is considered impossible to win. And this is mainly due to the fact that mosquitoes live where humans live, and we need people participation to have a capillary access to a territory, including private properties, and their involvement to maintaining the density of the species low to then apply SIT. But also it's a matter of acceptance of the technology you want to use on a territory that you need to build up, creating a trustful relationship with people living there. I firmly believe that, as the famous aphorism attributed to Galileo Galilei states, that behind every problem there is an opportunity. So starting from this belief, I asked myself, but is it possible to transform the threat posed by mosquitoes into an opportunity for the development of a community? And so I imagined a population of mosquitoes that attack and a community of people that respond in a collaborative way rather than in an individual way. And so I designed a high-impact action that, through the direct involvement of a community in a project, first of research and then of control using SIT, can not only lead to the successful elimination of the mosquito species in the area, but also could act as a driving force for the development of the community itself. And to test this idea, we selected a beautiful island, that is the Procida Island in Naples Gulf, as a field testing site. This island has unique features for an SIT-based mosquito control program. Because firstly, it's a small island, only 3.7 square kilometers. It has a high density of Asian tiger mosquito, and then a high density of human population here. There are about 10,000 inhabitants living on the island, and this number doubles during summer because of tourism. So the island has a density similar to cities, so it's a challenging place where to apply the technology. And the last but not least, there is an administration and citizens that are sensitive to environmental issues. So the first step in our project was to interact with these politicians or administrators and ask them help and support for our project. Firstly, helping us in selecting volunteers that could start the work with us to study the mosquito population. And so what was exactly what we did, and we designed an ovitrap monitoring over 1 year using ovitraps to evaluate the temporal dynamics on the island of Aedes albopictus population, and half of the ovitraps were managed by these volunteers. And the mayor itself of Procida Island served us as a volunteer, helped us a lot, just doing himself action in his garden, managing one ovitrap for a whole mosquito reproductive season from April to November. And this was a big achievement for us because of the positive example effects that it had on other volunteers, helping us in convincing them to participate to complete the program. I have here a very short message that the Major of Procida sent for us for this talk.
There's no sound.
Then, with the help of our volunteers, we involved 80 more families to study the spatial distribution of the species over the island using 100 ovitraps. And then in 2018, we finally analyzed the density per hectare of the mosquito population by releasing 20,000 sterile marked males and applying the marked release recapture technique with the help of 30 more families. Here in this picture, you can see the day of release. We did it with people of the island, students from our university, and the major itself, and the Conselho Rossello Lauro. So thanks to the active participation of citizens in our project, we collected baseline data about Aedes albopictus bionomics on this island. And with this data, we started to answer these three important questions that are required for the planning of the future SIT test on the island. When to perform the sterile male release, when to do it, and how many sterile males should be released to suppress the local population. So about the first question, we identified as the best period, April and May, because this is the period in which the population starts to arise after the winter. And it's important to do the release before then the density of mosquito reach a too high level, as observed in July and in September. We also observed a quite uniform distribution of mosquito on the island. So the whole territory should be managed and treated with sterile males and not just part of the island. And we observed a very high density, in some cases around 10,000 mosquito per hectare on the island in September. So in the top density period of the mosquito dynamics. And this underlines how it's important to act before that this density is obtained by the local population. All the results of this 5-year-long project has been recently published on PLOS Neglected Tropical Disease Journal. So if you want to know something more about our results, you can have a look to our paper that is freely accessible on the journal website. So the very high density that we observed in September in Procida highlights the necessity to work to reduce the mosquito density before to apply SIT. And this is a key aspect of SIT technology, as recently discussed in this paper published by researchers of the International Atomic Energy Agency we are collaborating with for our project. And so we planned, as the next step in our project, a larval breeding site elimination campaign to reduce the local mosquito density through community participation. And this was a key part of the project because most of the people on the island, they didn't know about larval stage of mosquito that occur in water, and then the simple way to fight mosquito that is eliminating breeding sites, eliminating standing water. So with this aim, during these years of activity on the island, we did a lot of efforts to engage the community and to invite them to participate in our project. And we organized public events in the frame of the European Research Night program to teach to citizens something more about mosquito biology and control methods and good practice they could apply in their garden to limit the mosquito spreading. With a special focus on children, or young people and students that are a very key resource in this community engagement efforts, because students can be taught on how to manage mosquito and to solve mosquito problem, and then they can teach their parents at home. So they are very powerful trainers that they can not only represent the future generation, make them aware about the problem and how to solve it could be a way to have future adults just ready to fight mosquito, but also they can teach their parents in the present and helping us enrich every family on the island. In September of this year, to further increase the participation of the community and to identify larval breeding sites, we started a campaign, a citizen science campaign using a smart app that is the Mosquito Alert app, by which citizens could signal and eliminate then larval breeding sites. And we have a very good reply by the population, of the population involved in the application, the use of this smart app. But despite the success of many of the activities we performed on the territory, As a scientist, we experience that we have not enough and proper skill to foster engagement with the community. Because community engagement, in our experience, was not only a matter of study and explain. We understood that relationship building with the community is the most important part of the story. And so it's not just a matter of involvement of a big number of people, because a community is not is more than the sum of the people living in a place. Community has its own story, its own traditions, and you have to work with them as let's say, a unique object, let's say. So not like the sum of the individuals. And so how and where to ask for an help to define a better approach to involve the community in our program. We try to imagine an alternative and interdisciplinary approach involving artists. And we were very lucky because in Naples, we have a very special kind of artists that are called the relational artists. They are students and teachers of the School of New Technology of Art of our Fine Art Academy in Naples. Relational art, most probably some of you knows what it is, some other not. If you want more information about it, you can have a look to the website of Tate Gallery website that is set in London. But briefly, in relational art, the audience is envisaged as a community. So rather than the artwork being an encounter between a viewer and an object, relational art produces encounters between people. Through these encounters, a meaning is elaborated collectively rather than in the space of individual consumption. And so this is exactly what we want to do using science. So we asked to these special artists if they could be interested in helping us, and they have a very big interest because they are special artists that are used to use the scientific methods too in their approach of building installation and working with people to create relationship. And so as a first step in our collaboration, we asked them an help to design a communication campaign for our project. And they produced for us two fantastic ideas. The first one is this acronym, ZZZ, that is the sound of mosquito buzzing. And that in Italian means zero mosquito area, zona zero zanzare. And then this big red circle that represents both the objective of the project, that is to reach zero mosquito area, but it represents also the community in form of a circle. And using a big object built by these guys, they started to work with us on the island to involve people and to feel as an important part of the community and to help us to participate to this scientific community growing on the island, working with us to control the mosquito. I will show in this very short video produced by these guys some images of the experiment we did together on the island. Last year, a very unexpected event occurred. That was the Procida Island was elected as the Italian capital of culture for next year in 2022. And the organization leading this project, it's a very interesting project that is putting a lot of efforts in the direction of community participation to cultural events, inserted in the program, in the official program, also a specific subset of activities that are focused on citizen participation, including citizen science. So together with the organization of Procida 2022, and together with the artists, we start to design a novel, some novel kind of activities to be performed on the island. And they are a very big number of a very big group of people, of students and teachers. And we designed an innovative door-to-door campaign with the objective to eliminate as much as possible larval breeding site and female mosquito on the island, using an efficient community engagement and relationship building approach. To do this, we are planning to act on the territory, so in the field, arm to arm, together, artists and scientists. So create something like mixed teams of artists and scientists and working together to engage the local community. We have designed new mosquito traps with a special design, always in with the idea to involve people as much as possible. That these objects will be 3D printed and will represent the present by which to start the relationship building process with citizens, because these artists are used to have this approach. They start with the present to interact, to start the relationship with people, and then from the relationship that starts, everything goes on. We are also planning a new creative representation of the community that will participate in our project that will be set up on the island as a big artistic installation next year. And we are also designing a novel, creative way to communicate through a big high-tech installation in real time on the island the results of the mosquito elimination efforts that people will help us to produce. I hope to have the opportunity in future to show you the results of our innovative approach that we will evaluate through entomological monitoring, but also by socio-economical analysis evaluations. And we hope to contribute with these efforts to open novel ways to fight insect vectors that could be then applied also in other parts of the world to win our battle against vector-borne diseases. At the same time, we hope to have a positive impact on the community itself by fostering positive interaction between community members, showing the importance of applying scientific methods to solve environmental problems, and helping to strengthen the relationship between citizen and scientists is so much important in a pandemic times like the present one we are living and experiencing. And so I wish to thank all the people that helped us in these 6 years now, including the manager of the Procida Island, Raimondo Ambrosino, all the other volunteers that helped us a lot, and all the members of my research team at University of Naples and collaborators from my university, from La Sapienza University, and from Centro Agricoltura Ambiente, Professor Romeo Bellini, that produced for us the sterile maize, as well as the colleagues from International Atomic Energy Agency that supported us a lot during these years of the projects. And of course, all of you for your attention. Thank you.